Did a bit of a quick update on this Sony ICF6800. As you can see, I've managed to replace, I think, 14 transistors now. I pretty much decided to do the whole lot. While I've got it apart, it's easier than trying to get away with a few. They certainly all didn't need replacing, but yeah, once they start dropping their gain, it's never going to get better, it's only going to get worse. This here is the main frequency selection. This is the little 4-gang tuning capacitor I was telling you about. It's quite a neat wee thing. Look at that. Love it. And as you can see, it increments round on a 10 position switch. Oh, no, not a switch, but a detent. So this gives 4 tunable capacitances, separate tunable capacitances, which basically tune the 1-gang tunes the VHF oscillator, which is this section in here. We also have 3 other frequencies that are mixed in with this oscillator to arrive at the main VCO frequency. It's actually quite I suppose a difficult thing to try and follow through, because the circuit diagrams is just as chaotic as a circuit board, really. So basically there is the VHF oscillator for the 3 interpolation oscillators. Here we have a buffer transistor, a FET mixer, which then goes through a low pass filter. We have a 10 meg oscillator here, which actually supplies the reference signal, but this is mixed in with the VHF, or it's not VHF at this point, because the VHF and one oscillator and the VHF, the other oscillator, the difference frequency through the last low pass filter is pretty much the same frequency as what comes out of the AM VFO, which is in that box there. So basically they arrive here at the buffer amplifier here, a couple of those level shifters into a 4013 flip-flop. This in turn drives, there's a buffer amplifier under here. I've also replaced those transistors. This here is then fed into the phase lock loop phase detector. That uses discrete components. It's actually quite a strange design, but I suppose back in the day phase lock loops were fairly new technology. These 2 transistors here is a sweeper, so when this circuit detects it's not in lock, it sweeps the varicap voltage onto that varicap down and right there to force the loop into lock. These other circuitry here, this is the buffer amplifier for the frequency counter. We have here a 10 meg oscillator. This is the main reference oscillator, and that is routed over to this 10 meg coil here. The analog circuit, we have the pig's nose ferrite core here, which is just a broadband input transformer into the first mixer. We have a roughly tuned second IF, or first IF here, which is just a couple of coils. We then go into this radio chip, as I said before, which basically, in shortwave anyway, it just converts the first IF down to 455, the second IF. Here we have the BFO circuitry. We have a couple of filters down in there. Here we've got I suppose it's 15 kilohertz wide. This one here, and there's a narrow one in there, which by narrow it's probably, I don't know, 8-9 kc wide. They're pretty basic. other than that, we've got a voltage regulator here, of course, and as I think I've already explained, this is the FM section. The FM section just takes the 10.7 meg IF, dumps it into this chip here, which is used as an FM detector, IF amplifying detector. The audio is switched through these switches here, which then sent off to the audio amplifier. So as I said, the FM section is just really not part of all this at all. It's basically 3 radios in one. On AM, the only part that has anything to do with it is this section here. But as I say, the VFO is shared from that to derive the kilohertz tuning between all the 31 meg bands in this section here. So that's basically it. To work on this thing's a pain, like I'll keep telling you that. But now I've got to actually put all this back into here, and as you can see, it's a bit of a nightmare because this here has got to be all, again, it's got to be fitted in here, and it's got to be, all the connections have got to be remade, of which there are 1, 2, 3, 4, 5, 6, 7, 8 sections. So yes, it's quite involved, but unfortunately it's pretty much guesswork whether I've found all the faulty transistors, which I must have because I replaced them all. I couldn't see anything of anything obvious. I've done a few voltage checks as much as I can with half the thing apart. So what I'll do now is I'll reinstall this main tuning gang, etc., and fire it up. I'll reconnect everything because it's not going to do much without it all being reconnected, and yeah, see if we can. We're probably going to have to try align this thing. Depends how much I've interfered with everything. I haven't altered any of the adjustments or any of the coils yet. I remember a couple I've done of these. Yeah, I was lucky I didn't really need to. After it was done, I think it was just a minor tweak up. But because it's got such a wide locking range, the phase lock loop, yes, it's just a case of getting this this tuning cap here to track correctly. You know, because it actually controls 2 oscillators at once, and one of the 3, depending on which one is switched, which is that switch there. So let's, oh sorry, not that one, this one, that's the mode switch. This one here is the 0 to 10 is one position, 10 to 20 is the next position, 20 to 30 is the third position. So there we have it. As you can see, it's not a logically laid out board. As you can see on the back here, there's coax cables and things darting around. But mind you, they've done wonders for a single-sided circuit board, and even a double-sided board, which would probably have similar issues in trying to get a decent layout because of so many subsections are used for different purposes. But anyway, that's the quick rundown of it. I might have time now to put that tuning gang back in which case hopefully we're going to have a working radio. The best laid plans of mice and men. Okay, let's do that and I'll get back to you.